Hi everyone, I'm LiJiaying, a second-year PhD student from the Department of PIA. In this video, I will talk about how to use R to manage and analyze data. First, we will quickly go through the slides and then go deep into R to run the code. Today, we will cover four aspects: the basic ideas and concepts, data structure, data management, and data analysis. Here is a flowchart to show the typical steps of data analysis, from importing data, preparing and cleaning data, to fitting a statistical model and producing report of data analysis. Next, we will introduce two important concepts that may help you understand R code more easily. The first one is function. We rely on functions to get all outputs we need in R. Here is an example. Min is the function name, and the input is written in the bracket. So if we run this line, we could get the mean value of the H vector. And the second concept is the package. Some functions are available by default, but most functions are stored in package, so we need to download and install as well as load the package every time we use them. We can use a library package to load a package as needed. And the second part is the data structure in R. Here is a visual example. Vector is one dimension. The matrix and data frame are 2 dimensions. An array could be more than 2 dimensions, and the list can be any combination of all data structures. The difference between matrix and data frame is that the columns of data frame can be different data modes. For example, the first column can be characters and the second column can be numeric values. The following page illustrates how to create different data structure using R, and we will discuss this later when giving the demo in R. And the third section is data management. After importing data sets from a variety of data sources, we need to prepare and clean data. We will cover the following 8 aspects: creating new variables, recoding variables, renaming variables, dealing with missing values, converting data type, sorting data, merging and subsetting data sets. I have summarized some commonly used operators, symbols, functions in the slides for your reference. And the last section in this video is data analysis. In this section, we will cover the following statistical methods, including descriptive statistics, correlation and covariance, t-test, analysis of variance, ANOVA, OLS regression, and PCA and factor analysis. For the descriptive statistics, there are several different ways to perform this statistics. You can compare the functions and choose the most suitable one. And the second is correlation and covariance. R can produce Pearson, Spearman, and Kendall correlation coefficients, and you can specify the method in the function. And you can also use the t.test function in the math package to conduct the t-test. And for ANOVA analysis, I mainly introduced the one-way ANOVA, including the ANOVA F-test and the multiple comparison procedure. And the fifth method is OLS regression. If you want to fit a linear model, you can use a simple LM function, and you can also get detailed results of the regression by using these functions. And the last method is PCA and factor analysis. You can use the SEC package in R to conduct the PCA and factor analysis. And this is a quick overview of data exploration and analysis. Now we will shift to RStudio. Yes. And I will illustrate the R code line by line. Okay, look at the 7th line. This line set the work directory, and the working directory is a location where our saves read files and save results. You can replace this directory with yours. I have provided guidance on how to find the working directory in a Word document. If you want to run the current line, you can just use the Command Enter shortcut to run this line. And by the way, the line 8 to 10 are the comments for the R code. And if you want to comment the current line or selection lines, you can just use the Command Shift C to comment the line, and you can also use the save shortcut to uncomment the line. And the first section will show several examples of our functions and packages. If you run this line, you can get a vector containing 6 numeric values. And you can also use the min function to get the mean value of the H vector. And you can also get the help information of this function, like how to use this function and the definition of each arguments. You can use the install the package to install a package and then load the ggplot2 package. For the data structures, the first one is vectors. There are 3 ways to create the same vectors, and this one will create vectors contain 3 text elements, and the treatment vector contains 5 elements of logic values. And if you want to find a specific element of a vector, you can use the vector subscripts. For example, this one will return the first element of the of the major vector, that is economics. And then you can create a matrix. We can show the matrix. Here is the matrix. The number is 1 to 20, and there are 5 rows and 4 columns. And the matrix is filled by column. And this is the default sizing. And we can also define the row names and column names of the matrix. For example, we can first cite the row and column names, and then define it at the values of the dimension names. I think the code for creating an array is similar to that of matrix, so we will just skip this one. And the most common, I think the most commonly used data structure is the creating a data frame. There's the patient ID vector, age vector that base the status. So we can use the data.frame to create a data frame. Now we can click this one, and we can look at the content of this data frame. We will subset the first 2 columns by this line. And we can also subset the columns named database and the status. And we can also use the $sign to subset the data frame. Finally, we can create a list and combine any type of the data structure in this list. And it contains text elements as well as numeric. It contains the vector as well as matrix. Next section is the data management, and we will create a simple data set, namely my data. There are 2 columns. We can create a new column, namely sum x, by adding the x1 column and x2 column. And we can also create a min x column to calculate the mean value of the first two columns. Okay, I think we can show the sum x and min x column. There are other methods to create the new variables. You can use a help information or help function to see the information of the new functions. And then next is recoding variables. We can create a sample data frame about the leadership. And this is creating a data frame about the leadership. Then we can remove the individual vectors. If we want to recode the numeric age variables into categorical variables, we can use these lines. For example, we can, when the age is more than 75, we define as elder, and then 45 to 75 as middle-aged, and less than 45 as young. And this is another method to recode the variables. If we want to rename the variable, we can use library the reshape package and rename the leadership data frame. You can see the old name is manager, as well I think as well as date. And then we can run this line. So the manager has been changed into wait a minute. Okay, the manager has been changed into the manager ID, and the date has been changed into the test date. For converting the data type, okay, for the missing value, we can use is.na to know whether the elements are missing. And we can also recode the 99 to missing for the variable age. And we can also use na.omit to delete the incomplete observations. So the incomplete information will be deleted. And then is the converting data type. First, we set a date format, and we will change the date in the leadership to another format. And here's another example. We will return today's date. Today is January 30, and we can change the format to what we need. And we can also sort the data set based on certain variables. Here we also attach the leadership data side and order the leadership data side based on gender and age. And you can see sort by gender and age. The minus sign means the descending order. Now we detach this leadership data side. And we can also subset the data. We can select the observations or rows based on the date. So we first change the data type and cite the start date and end date. We can select the observations during this period. So the new data, the date is this date is during this period. And we can also select the variables. For example, we can select these columns, column 5 to column 9. There are several different methods, but will return the same results. Also, we can drop the variables. Just use the minus sign. And now we begin to conduct the data analysis. Here we use the first one is the statistical descriptive statistics. We like to use the method 5 to conduct the descriptive statistics. You need to install the package SAC and elaborate this package. And this also need to run this line. Also need to run it right and describe the distribution of the data set. And next is the correlation and covariance. We create a matrix. First, we create a matrix based on the data set state X77, and we use the data related to the 50 states in the US, and we could get the covariance and correlation matrix. And we can also specify the method of the correlation coefficients. For the t-test, I think the independent t-test is very simple in R. We can use the t.test function in the math library. The probability is the prob is the probability of the imprisonment, and SO is the indicates whether the state is a southern state. So the data is from US crime. And this test can answer the question, are people more likely to be imprisoned if they commit a crime in the South? And we can conduct this one. And the results show that the answer is yes, because the test rejects the null hypothesis. And next one is one-way ANOVA. We need to elaborate this package and attach the data cholesterol. In this case, the 50 patients will receive one of the 5 cholesterol reducing drugs regimens. And the question is, which treatment produced the greatest cholesterol reduction, or which treatment is the most effective one? And we first table the treatment and calculate the mean and the standard deviation of each treatment, and conduct the ANOVA analysis, summary the results of analysis. We can also plot these results. Here's a plot. We can plot the mean of each treatment as well as the 95% confidential interval. And but the typical F-test can only answer the treatment effects are significantly different, but we cannot know which one is the most effective one. We can further pairwise compare the group mean. So we can use this one. We can get a pairwise comparison plot. 2 times treatment versus 1 time. And here is another plot. In this plot, if the treatments have the same letter, they are not significantly different. So the most effective one is drug E. And the 5th method is OLS regression. I provide examples of the simple linear regression, as well as polynomial regression, and also the multiple linear regression. I think this one is the most common. Here is the summary. Here is the summary of the regression results. We can get the confidential interval of the coefficients. And we can elaborate the CARP package to calculate the variance inflation factor to know the amount of the multiple collinearity. Yeah. And we can also find outliers and influential observations using the influence plot. Here is the influence plot. We can know the outliers as well as the influential observations. Okay, the last two methods are PCA and factor analysis. We can elaborate the SAC package and also draw a plot to determine the number of factors. Here is the plot. I think this is similar to the SPSS outputs. So the number of factors should be 2. And then we can conduct the PCA analysis without rotation and with rotation. And finally, we can get the principal component scores. And I think the process for the factor analysis is very similar to the principal component analysis. But at last, we can use a diagram to show the results of the factor analysis, like this one. We can use a diagram to display all the scores and the relationship between the factors and the principal components. Yes. And that's the end of the R code.